Today, we're going to dig into the ground right beneath our feet. This huge, growing, and, surprisingly influential world of pavement.
Seriously, wherever you are right now, just look down. Are you on a sidewalk? A road? Maybe you're inside a building? Well, odds are you're standing on the surface that has been sealed off from the earth below.
So there's a technical name for all this stuff. Impervious surface area, or ISA for short. And it's exactly what it sounds like. It's the roads, the rooftops, the parking lots, basically any surface we've built that stops rain from just, naturally soaking into the ground. And as you're about to see, it is everywhere. To give you a sense of the sheer scale here, let's just look at one part of the puzzle, roads. The world's road network now stretches for an estimated 64.7 million kilometers. That is long enough to circle the entire planet over 1,600 times. It's just staggering.
Okay, so we've built a ton of it, a mind-boggling amount. But what does it all mean? What are the hidden consequences of covering our planet in so much concrete and asphalt? What does it actually do to the systems that keep everything running?
Well, to answer that, we first have to understand what this impervious world is even made of. It's not just one thing, it's this whole complex system of structures that are all interconnected. You can really break it down into three big chunks. First up, you've got roads. They're the most widespread part, the things that connect everything. Then you've got rooftops, which kind of form the structural core of all our towns and cities. And then you have parking lots, and the research really calls these out as maybe the most inefficient land hog of them all. And when you look at road building, the scale is just wow. It's particularly huge in a few key countries. The United States, India, and China are way out in front, each with over 5 million kilometers of roads crisscrossing their landscapes. I mean, that's just a massive global commitment of land and resources right there.
All right, so let's move to the next piece of this puzzle. Rooftops. Globally, if you were to add up all the land our buildings cover, it would be about 250,000 square kilometers. Now, to put that in perspective, that's an area roughly the size of the entire United Kingdom, just completely sealed off from the sky.
And this brings us back to parking. This quote from the source material really hits the nail on the head. See, roads connect us, and rooftops give us shelter. But parking lots, for the most part, they just sit there, and they take up an absolutely astonishing amount of space. The numbers here are they're wild, especially in the US. There are at least 700 million parking spots. And get this, that works out to nearly 5 parking spots for every single registered car. Think about that. You've got one at home, one at work, and then a few more just waiting for you at the store or the movies. And most of them are empty at any given moment.
So what's the total footprint of all that empty asphalt? Well, if you combine all those US parking spots, they cover a land area the size of 2 entire states, Vermont and New Hampshire. Just gone. Paved over. For storing cars.
So, okay, we've established we have paved a massive, massive portion of our world. Now let's get into the domino effect, because this is where it gets really interesting. These are the hidden costs of our concrete planet. One of the biggest and most direct impacts is on water. You can kind of think of it as a hydrological squeeze. See, when we pave over natural ground, we basically short-circuit the water cycle. Rain hits the pavement, it can't soak in, so it just rushes into drains at high speed. And here's the irony. This leads to both more intense flash floods and more severe droughts, because we're not letting that water recharge our groundwater. But the impacts really don't stop there. Pavement soaks up and radiates heat, creating these urban heat islands that make our cities dangerously hot. It also concentrates air pollutants like PM 2.5, from all the traffic. And maybe most critically, it just carves up natural landscapes, creating what biologists call edge effects.
And here's a number that shows you just how deep that fragmentation goes. Today, a staggering 70%, 70, of the world's remaining forests are within 800 meters, that's less than half a mile, of a man-made edge, like a road or a farm. There are very, very few truly deep, wild places left.
So here's the bottom line, and this is a really crucial point from the research. This carving up of the natural world, it isn't just one problem among many. It is now considered the single largest threat to biological diversity on the entire planet. But here's the thing, not all development is created equal. And when you dig into the data, you see these two very different philosophies for how we build our cities. And that tells us that how we build might be just as important as how much we build. This chart right here is incredibly revealing. It shows the amount of paved over surface per person. So in the United States, it's almost 300 square meters for every man, woman, and child. In India and China, it's less than 80.
Now, this isn't just about population. It's about two fundamentally different ways of developing.
And here's that difference in a nutshell. The North American model is super land-intensive and totally car-dependent, right? It's all about low-density sprawl. But in contrast, a lot of the rapidly growing Asian cities have focused on dense, vertical growth built around public transit. They're just two completely different ways to house a population.
And this choice we make between sprawl and density, it has some massive implications for our future. As our cities keep expanding, they are on a direct collision course with our food supply. Projections show that over half of all new urban land could be built directly on top of the fields we use to grow our food.
Now, I know this all might sound a little bleak, but the science also points toward a pretty clear path forward. The goal isn't to stop building. That's not realistic, but to start building much, much smarter. And we actually have a pretty good toolkit. We can start integrating nature back into our cities with things like green roofs or permeable pavements that actually let water soak through. We can get rid of these outdated parking policies that force developers to build huge, unnecessary parking lots. We can use all that rooftop space for solar panels and gardens. And of course, we can strategically protect the last few truly unfragmented habitats that are left.
Look, at the end of the day, our world is going to keep growing. That's a given. The real question this all forces us to ask is about the choice we have for our future. Are we going to continue to just pave over the planet, or are we going to learn to build cities that work with nature, not against it? What kind of world are we going to choose to build?